Howdy once again, it's tubalcain, your YouTube shop teacher, and in this video I'm going to do a repair job. And you might remember several months back where I obtained this Greenfield tap wrench, a number 7, at a estate auction, but it was missing the movable jaw. However, the threaded part was included. I'm glad it was, because that's a left-hand thread. But the whole impetus of this video is to make this movable jaw, and this is a mock-up of it made out of aluminum. I'm going to make it out of tool steel, and the hard part of this is to put this V in here. In the previous video, whatever that number was devoted to talking about putting a 90-degree notch in the metal and centering it. That's the hard part, is centering it. I showed several different ways of doing that in several different pieces. So I'm going to use the simplest method for this, because I just don't think it's all that critical. But when I start a project like this, I generally make a little wooden mock-up, because I didn't have any dimensions to go by. I did, however, have another Greenfield tap wrench, a number 5, in the same style. Now, if you look over here, you will see that I have a whole series of Greenfield tap wrenches. Not all sizes, but 3 or 4 sizes here. But these are the newer version, some of them nicely case hardened. This one, if you compare it, well, yeah, with this one that's the same size, they're both number 5s, but they changed the design at some point. I believe this is the older one. They're both good looking, but a difference in design. So this big one here, the number 7, also is the older design. In order to install the new jaw, this fixed jaw has to be removed, and that's done with this set screw on the side, backing it out, and you can see there's also a dimple in there that lines that up. This is hardened as well. Then this jaw can be inserted. Now if you look at this, the way the handle is made, well, why isn't that coming out? There it is. Oh, that was a long thread and a very fine. So the left-hand thread goes into this piece like that, and the two jaws, or the two threads working together, provide a rather fast movement, as well as to lock it in place where it doesn't tend to back out. So it might seem a little bit overcomplicated, but it's certainly a nice feature in these Greenfield tap wrenches. I think it helps to make a prototype, and that's what I did. But I have this piece temporarily held in place by Loctite, but in fact the final piece, or the way they designed it at Greenfield, is there was a hole drilled in here with a little pin, and when I take this out later on, you'll be able to see the evidence of where the pin had sheared off, and that's probably what happened. And then somebody lost the jaw along the way, and that might have been many years ago, and I almost threw this away at the auction, if you recall, when I picked this up at the auction. But in order to put these together, this handle here has to be in about the right position in order to get this in. I'll have to back that up just a little bit more. And then, I might be on the wrong side here, like that. And then I can back that up to engage that thread, and then it moves in and out, and at this point, and I have to get that position just right, then the other jaw would be put in place. And this particular number 7 is 19 inches long. I believe they made bigger ones. I don't know exactly what the numbers were in that system. Somebody can put that in the comments, but that, as you can see, is for larger taps. This is a 7/8 tap, I believe. So you use the size tap wrench that is proportional to the tap that you're using. I very seldom do large work like this, and naturally you see me use these smaller Greenfield tap wrenches and stir it as well. So that's what I'm doing. Let me take this back out off camera, and then I'm going to remove the threaded part here to show you that. I had to heat this piece up in order to get the Loctite to loosen up, and then the residue of Loctite was removed from this. Now on the final product, I am going to use Loctite again because I had a heck of a time getting that out, so it really holds it secure. And the other thing is I don't want to drill another small hole in this because there's already one hole drilled in here with the broken off pin, and you might or might not be able to see it right here where that scuff mark is, because that, well, you can see just a little bit of the circle there where the pin was driven in. That may be a hardened pin, I don't know, but I don't want to drill another hole anywhere near that, so I'm going to use Loctite, and I'm glad I don't have to remake this piece because that's a left-hand thread. I want to make the jaw out of tool steel, and I did not have any precision ground stock that size, so this was a piece that I obtained from an auction that was tool steel. It was just as hard as can be, and I did anneal it, and it's going to be just what I need here. It's about the right thickness. It's heavily scaled from that. It has a lot of holes drilled in it, but by working around the holes I still have plenty of material to make this piece out of. So I'm going to prepare that, saw it, and then mill it down to the right width, and I may have to change the thickness just a little bit, and the right length. In other words, get it ready for drilling this hole and producing this geometry on this end. It would be handy if I had some tool steel to start with. I'm going to waste about a half hour on that, and this is an odd dimension. It's about 685 thousandths, so I believe this is about 3/4. Yeah, that's 3/4, so I have to reduce it a little bit in thickness as well. Okie doke, I've been about a half hour on the bandsaw and then the milling machine, and I took this piece of tool steel down to, well, some rough dimensions here, but everything is squared off nicely. And the only dimension that I have right now that is correct with this is the thickness. So it's the same thickness as this. The next thing I'm going to do is take it down to width so it'll fit into this slot. And that width is 0.936, so I have to take off 136 thousandths, and I already laid that off, but then I'll also mill it close to the line, and then I'll use my micrometer to get it real close because I want a nice fit. But it's starting to shape up, and in about a half hour we'll have her down to the basic dimensions. Now this is too long at this point. Why is it too long? Should hold that up. It's because if I should mess something up here, I got a second shot. I haven't painted myself into the corner. Also, I'm not totally sure of what the dimension of this piece is since it was missing, so this is kind of a guess on how long this is. And I made it, I guess, about the length of the other fixed jaw. Alright, over to the mill. I'm using one of these brand new Niagara 3/4 inch diameter cutters, and I'm set up on a parallel and ready to mill it close to the line, and then I'll finish by measuring and then taking it to the final thickness of what did I say, 0.936. I always write down dimensions like that. Be sure and wear your safety glasses and practice your safety rules when you're working in the shop. It's 0.941, so I have 5 thousandths more to go, and I'll raise the knee by 5 thousandths, and this should be my last pass. There it is. I'll take one more measurement before I take it out. And there it is, the rough blank. And I got a pretty decent fit in there. I want it to be a sliding fit because it's going to move back and forth. So I've got a good fit, probably within a thousandth or so. And when I originally took this apart, you can see I had to dress it up with a file because it was gouged in many places, I suppose, from turning large taps over many years and forcing that draw at an angle with the torquing, and that's what caused that to dig in, I would think. So I did dress that up. You don't see that down on the fixed end much, but it's all up here on the moving end. Alright, I'm going to lay this out now for this 90-degree notch and these reliefs. Now let me do the layout. I have already made a center line using my height gauge on the surface plate, and I determined that the depth of this V is 210 thousandths, so that's the cross line here. So using a small combination square and putting my glasses on, I'm simply sliding this back and forth until I'm right on the intersection there, and marking it, and then flipping this like that, and then finally the reliefs are located from this point right here, and those aren't very critical. Something like that. And that completes the layout. I'm ready to mill. In the previous video, number 393, I showed several different ways of how to cut a 90-degree V notch. So go back and watch that, because I don't think I'm going to cover it in as much detail in this video, and I'm going to do it by the simplest method, which is to put it in your vise at 45 degrees and using a standard end mill, just mill the corners away and mill the notch down in here to the lines. How accurate is that? Well, certainly accurate enough for a tap wrench, and it was quite accurate when I did it in this other video. So go back and watch that if you haven't caught that. So let's go on over to the Bridgeport mill. Now the work has been positioned by setting it on this 45-degree triangle, but you could use a combination square head, a small one, that would work, or even a drafting triangle. It isn't too critical. This is certainly going to be close enough for who it's for. And then I probably should change end mills and put a little bit smaller one in there, but you know, 90 degrees is 90 degrees, so I'm simply going to mill it to the two lines there to form that notch. There I am, right on the lines. And now milling it down to the top line. This line right here. That's just straight milling. And now the work has been flip-flopped, and I will mill the final surface there, the final corner. And so on. Looks like a pretty good fit. So now I will chop it off at the layout line here, which will give me this length, just a hair longer. I made it actually a 1/16 inch longer. Again, that's just a guesstimate because I had nothing to go on at all. So I'll saw that off and mill it, and then get ready for the final operation, which is this hole. I laid out the hole using my height gauge by finding half of the thickness and half of the width here. Simple enough, but decided, in fact, I think I'll do that on the milling machine, locating the center with a wiggler or a center finder, edge finder I mean. And the hole of all things is to be reamed 13/30 seconds. Now where they came up with 13/30 seconds, I don't know, but that's the way this piece is, and that was probably decided upon during the days when they still were making Model Ts. So I think this thing is pretty old, but I'll drill it in the milling machine and then ream it 13/30 seconds. Since that's such routine work, I do not intend to show it. Be back momentarily. And the final operation, reaming at slow speed, 13/30 seconds. It's already been drilled one size under. The hole is 9/16 deep, an extra 16th over what I had planned on. We got a good fit here. So let me just go ahead and fit it up before heat treating here and see how it looks, how it works, even though this isn't fastened in yet. Good fit. Just a little longer than the aluminum one. And it's not going to return to the home position until I put the Loctite in there, so I have to pull it back right now. But it will accommodate this bit, tap is a 1 inch, and I suspect that the number 7, if I would look it up, has a maximum capacity of a 1 inch or thereabouts, unless you're in metric land. There we go. So let me get it hardened and tempered. I'll do that off screen because I've done that so often. And then I'll fasten it with Loctite, and that'll be tomorrow. So I'll wrap this video up tomorrow, which to you will only be 2 seconds away. Well, guess what? I just went up and reviewed my video called Tips 303 Discourse on Greenfield Tap Wrenches. And of all things, after looking at the video, I see from the video that I already owned a number 7 Greenfield tap wrench. I seldom do work this large, tap things that large, so this was set aside where I keep some of my bigger stuff, and there it is, all the dimensions that I would have needed. However, this is the newer one, and that man, Ezai, was a friend of mine, Larry Ezai, and he passed away some time ago, and I bought a bunch of his things at the estate sale. But you can see that this is a relatively modern one within the last 20 years. Larry used to make airplanes, so he did that kind of work, pardon me. But the older number 7 is quite a bit larger and more clumsy and heavy looking than the later one. Also, the later one like this does not have the beautiful color case hardening on it. It's more of a black parkerized finish, I would call it. So the finish is not so good on the newer one, but I just had kind of a laugh that I could have so much stuff that I don't even know what I got. You know, that's the kind of hoarder that I am. So anyway, I thought I finally had a number 7 if I ever do big work. Well, now I got 2 of them. So all right, that's just a little bit of an aside. Be sure and watch this video if you want to know a little bit more about these Greenfield tap wrenches. And there it is. The number 7, reconditioned, ready to use. Now I use that permanent type Loctite in there. You can get that off with heat, like 300 or 400 degrees. It's not like you have to turn it red hot or anything. So I have yet another large tap wrench. Probably would not have even done this project if I had remembered that I had this other number 7, but this is the number 7. Where is it? Right there. That concludes this video. Thanks for watching. Watch my 800 other videos if you're so inclined, and please subscribe. Thanks for watching. This is tubalcain saying so long for now.